Welcome back. Last time I was putting the crankcases together. That's all done now, so I can crack on with either putting the cylinder head back on it or putting the clutch back in, and I've opted to put the clutch back in it first. No particular reason, it doesn't really matter which way around you do it, I'm just doing it that way. So the first thing I'm going to do is clean all the clutch components, because we don't want to put anything back in dirty, and one of the biggest contaminants in a modern engine is the clutch. So I'm going to clean everything as best I can and then put everything together.
I just thought I'd do a little bit on how the oil pump works. So even though I'm actually going to move the outer, but it's actually the inner that moves in normal operation, I just can't do it one-handed. So as you can see, that moves around and you end up with a big gap here that pulls the oil in, and then as it squeezes it, it pushes the oil out of the pump at higher pressure. What it's doing is it's pushing oil in and out of these gaps and through the housing in and out of the oil system. It's quite a complicated little design, but the finish on it has to be really good. So as you can see on this one, the finish is really good. There's basically no pitting or anything. What you find is if they've had any debris through them, they get quite pitted on the surface, and that obviously reduces the efficiency. So that one's looking pretty good. I can just pop it all back together and pop it back in the bike, and then I can put the next bit together. Before I actually fit the clutch basket, I've had to fit the oil pump drive, which you can see drives the oil pump gear. The chain looks very slack, but it can't come off the rollers, and that way there's no sort of tension on anything to sap any power. So that's all tickety-boo. So all these bolts, anything that bolts inside the cases, I clean off the threads with brake cleaner in the case and the bolts themselves, and then I give them a little dab of Loctite just so nothing will come out when the engine's in use. So now that's in, I have to line the clutch basket up with these slots here so it drives, and the clutch basket literally just slides into the engine. So this is the clutch basket, the clutch outer, and the gear on the back of it meshes with the primary drive on the crank. So this is the end of the crank. So if I turn this, the crank moves, and obviously when the engine's running normally, the crank drives the clutch. But this, which is our gearbox input shaft, still moves independently of this, because we don't have the rest of the clutch in yet, so we don't have anything to drive that. So these are the extra bits of clutch. So this splines onto this shaft, and then this will fit onto here when I get it in the right place, and then these are our friction plates and our steels. So the steels with the teeth on the inside lock to this, and the squares on the friction plates drive on the clutch basket. So when they're pushed together with spring pressure, the friction involved transfers the drive from the outer to the inner, drives the gearbox. Fairly straightforward. When you pull the clutch lever, a little push rod sticks out of here, lifts the pressure plate, takes the tension off the plate so there's no friction, and the two things are disconnected. The interesting thing, of course, on modern stuff like this with a slipper clutch is this has the ability to do this. Here we go. Tell you what, we'll come back to that in a second when I've set it up right. So on the back of the hub, you can see these little ramps, these bits, and these locate into these ramps here on the backing. So what happens when if the engine tries to go, in fact, sort of drive the wrong way, as in there's too much engine braking for how fast the gearbox and the wheel are going, what happens is the clutch, because it's not being driven anymore, if you can see that, rides up the spring a little bit. That takes the pressure off the pressure plate and allows the clutch to slip a bit. So that is how your slipper clutch works. Slightly awkward to show you one-handed, but hopefully you got the idea. You can see in here that I've torqued up the clutch nut and just tabbed it over. I tend to only use one of the tabs so that you can use the clutch nut a second time. So these springs here, there's actually 4 of them, and what they do is they just tension up this this hub so that it needs a certain amount of tension from the engine trying to slow down too much before the slipper clutch slips. Because if you take some of these springs out, or even just bend the tabs out of the way, the clutch slips considerably more easily. So it is, you know, adjustable to an extent. So we've got all that, we've got the stack back in, the clutch pack back in. So the next thing to do over here is to get the pressure plate which goes on the front, and then you have the normal clutch springs on here, and they create the friction, they create the pressure to have the friction to actually drive the clutch. It's all relatively simple, but yet surprisingly complicated at the same time. That's the clutch all finished now. So I'm not going to put the water pump on yet, because I like to keep the engine sitting fairly flat on the bench, and the water pump just sticks down a little bit and gets in the way. So I'm going to put that on fairly late, just before I put the sump on. So the next thing to do is put the cylinder head back on. Thanks for watching, and join me again next time while we're putting the cylinder head on and talking about cam timing. I bet you can't wait.